Okay, this might look like you have to do the big full boxes on critical path, but you don't really need to if you actually read the question. But I'll do that on the next slide. We've got to just get the earliest starting time for activity I. Well, that's the start of I, yes? So we just need to work out what is the shortest path to get there with the lowest value. If I just follow straight this path, it has taken me just 2 to get there, right? If I take another path, this one has taken me 11 to get there. If I try another path, that has taken me 3 plus 1 plus 6. That's taken me, well, 3 plus 1, 6, that's 10. And if I try another path, this path, it's 3 plus 4 plus 5 plus 6. If you look at all that, that is 18. So the actual earliest start time for I is 18 because it's the shortest path, the biggest value to get there. That's all it is. All right, let's delete all that. Now we do know that we're going to take, always going to take this path so far. That must be on the critical path, really, when it comes down to it. It's 18. So it says determine the value of P in days that will create more than one critical path. So you haven't got many points to really consider. You've only got this point and this point after that to get there. Now, if we were to follow H, there's only one way to get to H, is to go like this, yes? So if only going that one way, that's 3 plus 4 plus 10 is 17. And we've already got this 18 on the other side. So whatever P is, it's going to dominate that. So to get to here is actually 18 plus P, right? So you got 18 plus P. If we go this side, it is 18 plus 5 is 23, yes? So to get to 2 critical paths, this path and this path must be equal. And so for that to be true, you will find that the blue path takes 5 and the green path takes 4 from the K and 1 from the P. So that's the only way to make it 5 is to have 1 from the P. So it's 1 day. Make that look like that. So as you can see, we haven't actually done any of that normal critical path analysis. We're just comparing routes so far. All right, let's clean up some of this mess. If the value of P is 6 days, what will the float time be of activity H? Well, again, we got this 18, and if P is 6, then what do you have? 18 plus 6 gives us 24 coming in here, right? And from this point all the way down here, so it's 3 plus 4 plus 10 is 17. So we're comparing 24 and 17. So the float time for H is the difference between those two numbers, which is 7 days. All right, now, although some of you probably understood what I said last time I explained this problem, I'm going to do it again with the boxes just to make sure you get this. So it's just exactly the same as I did before, but now I'm going to do all the boxes for you just to prove I was right. It didn't ask for the critical path, so it wasn't really that critical. To see what I did, wasn't that critical? So we're going to do our forward pass, yes, so 0 here. 0 plus 3 is 3, and then we've got 3 plus 4 gives me 7. And then coming in, we've got lots of coming into this point here, haven't we? So we've got 7 plus 5 is 12, 3 plus 1 is 4, and 0 plus 5 is 5. I choose the biggest number, it is 12. Then coming into here, we've got the 2, and coming down, we've got the 12 plus the 6 is 18. So we have the 18. That already answers our question A, because the first box is the EST. Let's continue with the rest of the thing. It's a bit harder to do this because this ends up being 7 plus 10 is 17, and this is 18 plus P. Well, you have to choose 18 plus P, believe it or not, 18 plus P, because we've got no other choice. This is 18 plus 5 is 23, and then this is 18 plus P plus 4, so that's 22 plus P, and that's where we can see the difference. We've got 23 and 22 plus P. Well, the only way to make both of these here critical, so that it is 23 here, both paths are going to be equal, the only way to do that is to make P equal 1, so it is 1 day. All right. Now, having done all that, it says if the value of P is 6, so we can actually change some of these numbers. It's not 18 plus P anymore, is it? It is 24. So we can eliminate this. Oh, I better put back that side of my box. Got a bit carried away there. And so 24 and 17, I'm going to write that down. That's going to be 24 here. So we got, actually, I don't even need to fill it up to it for stake. That's 28. The difference between these two numbers tells me the float on H. Okay. And so that tells me that we have a float of 7 days. Now you could have worked your way backwards, so let's just do the working way backwards just to prove it. So if this is 28 minus 4 is 24, 24 minus 10 is 14, and you can still see the same thing with the float at the beginning there of 7 days, but you can also see the float this way, and this actually is a more effective way of finding float. Let's do the rest of the boxes just while the hell we're here. So 14 minus, well, let's do all of it. So let's do right from the beginning. 28 minus 5 is 23 coming in there, but we had the 24 minus the 6 is 18. So we actually have to choose the lowest number, don't we? So that's the 18, that's the 24. Going back against here, there's only one going backwards, so it's 18 minus 6 is 12, so we choose the 12 that goes in here. 18 minus 2 is 16, that's not going to be the number coming in there. 12 minus 5 is 7, so we've got a 7 coming in here. And that's why we get the problem, because this is actually now 7, isn't it? And so suddenly it does look like there's no float on H when you do a full critical path analysis. So you can just see why I talk about this being important. And so 7 minus 4 is 3, 12 minus 1 is 11, 12 minus 5 is 7. So we choose the 3 there because that's the lowest number, and then 3 minus 3 is 0. So there's 0. Very important to note that, like, when you get a triangle sort of shape, and this end is on the critical path and this end is on the critical path, but this activity is not on the critical path, you won't find the float unless you look at what's happening at the end of these two little red numbers coming in. So my technique is the bomb. It's the best. That's why you click like and subscribe to my channel. Okay, so they're going to build a second barn. Starting to sound like some sort of Amish movie here. So we got this dummy activity, which we can see here, and it's shown on this network, and it says explain what the dummy activity indicates on the revised network. Well, basically what's happening here is this point here is now directly connected to this point. It's like they're sort of, you jump immediately from one to the other. So that means now K doesn't just have H as a predecessor. Because of the dummy, C and G are now immediate predecessors. So C and G are immediate predecessors of, we're going to call them activities. Activity